Okay, so practice test. If you know how to do this, you're good. If you don't, well, you got one more day. What are you looking for? Okay, suppose that y varies inversely with x. Inversely. Inversely means that x times y equals the same number. And y equals 5 when x equals 2, write the function model. So what that means is x times y is equal to some number k. That's what our function is. We got to figure out k is. That's very easy to do. X and y is 2 and 5. 2 times 5 is equal to k. So 10 is what my constant is. And so my equation is x times y is equal to 10. Or I could have y equals 10 over x. Both of those would be good equations. You do not need to give me both. Both of those are versions of inverse variation. Okay?
10 equals k is not.
No. Because of this line right here. Write the function model. K is not my function model. K is just my constant of variation. The function model has to use x and y and k. I have to put the number in there. I have to write the function that fits that. X times y equals k. What is k? K is 10.
5 by 2, you get 5.
Yeah. But I have to set up the equation. Remember, it says write the function model. Write the function model means it says give me the equation. You got to give me this or you got to give me that. Okay? That's what it's asking for. But this helps you figure out what the k is that you have to put into it. Now it says do it again with direct variation. Direct variation means that y divided by x is what your constant is. Okay? Direct variation means that I do my division. I varies directly, that's division. Use the same y and x. 5 over 2 is equal to k. So that means my answer is y divided by x equals 5 halves, or y equals 5 halves x. Either one of these is what you need to have for your answer. For direct. Part 1, indirect. Part 2, direct. It actually asks you for both out there. Question number 2. Determine if the type of variation between the two, and then write the model for it. Same idea. Same thing, only you're actually determining whether it's direct or inverse. Remember that direct, y divided by x equals the same number each time. Inverse, x times y times x equals the same number each time. So that's what I want to do. What do I get? Do I multiply and get the same number each time, or do I divide and get the same number each time? Glancing at this, it looks like multiplication is going to work, right? If I multiply these two, I end up getting 3. 3 halves times 2 is 3. 1 times 3 is 3. Half of 6 is 3. If I multiply them, I got 3. Why did I do multiplication before division? Because it looked like it, just glancing, that multiplication would work. If these do not all come out the same, try division. Take y divided by x. If that's the same each time, then it's direct. This one is multiplications, so that means I have inverse variation. Which means that y times x is equal to 3. What did I get when I multiplied them each time? Got 3. Suppose the y varies jointly with a and b and inversely with t. And y equals 7 when a is 3, b is 2, t is 4. Find y when a is 2, b is 4, and t is 3. The key to these problems is setting up the original relationship based on that this first part of the sentence. Okay? This right here is when I need to set up my relationship between y, a, b, and t. So I have y. Varies jointly. Jointly is direct. Okay? Which means I divide y by a and b. Inversely means multiplication. So I have y times t. That's the relationship of my four variables. Y is times t and divided by a and b. That's the positioning of the four variables. Now, I take these four, set them up. 7 divided by 3 times 2 with 4 on top. Y, t, a, and b is equal to find y. Ooh, we don't know. When a is 2, b is 4, and t is 3. Solve for y. So then you just start working it out. So this one I get the 2's cancel here. And so that gives me 2. So I get 14 thirds is equal to 3y over 8. Okay, got to solve for y. Multiply both sides by 8. Divide both sides by 3. 8 times 14 is 80 plus 32. It's 112, right? Yeah. So I end up with y equals 112 over 9. Yeah, multiply both sides by 8. Get rid of the 8 in the denominator and the 1. 14 times 8, 80 plus 32 is 112. And then divide both sides by 3 to get the y by itself. 3 times 3 is 9. It's a 9 in the denominator. 112 over 9. That's your answer. Okay. Multiplication, division of rational expressions. First one, all you got to do is just start cross-canceling, reducing as best you can. Yes, what?
How'd you get 9?
Okay, so you got to get rid of this 3 here, right? So how do I get rid of the 3? I essentially, here's what I really want to do, multiply both sides by 8 thirds. So then the 8's cancel and the 3 cancels, what do I get? I get y. 8 times 14 to 112, 3 times 3 is 9. Does that make sense?
I feel like you used to do it differently. Like
No, it depends upon the problem. I've got more numbers going here. The other ones, most of the ones that I did examples did not have as many variables in it. And it all depends upon how it's set up. All depends upon how it's set up. You need this. You need to have this right here. Figure this out. This will be filled in with one set of numbers. And this will be all but one of them filled in with another set of numbers. That's what I have here. Put in the one set of numbers. Put in the other set of numbers. And then it's all multiplication and division after that. It all depends upon what you have. I will do it different ways depending upon what my problem is. But that's what I did here. Multiplied by 8 thirds to get the 3 and 8 to cancel here to get y by itself. Yeah.
So I just cross multiply. I got the same thing.
Yeah, if you did cross multiplying, you get the same thing anyways. So yeah, if you cross multiplied, what do you get? You get 112 equals 9y. Divide both sides by 9. What do you get? 112 over 9. Same thing. Okay. I don't think, for some reason, I don't always think about cross multiplying first thing. I don't know why. Sometimes I just don't. And frankly, I don't care. I'm going to be honest. Here's what I'm looking for. I'm looking for the setup. I'm looking for this stuff here. I'm looking for this. And I'm looking for that. I need to see the setup, not just the final answer. I see the final answer, I'm going to assume you got it some other way than how you were supposed to get it. Either through wandering eyes or something else. I need to see the setup as well as the answer. Okay? So, going back to this, start cross-canceling, reducing whatever you can. So with the numbers, do it numerically first. 3 and 15, that gives me a 5 here. 4 reduces 6, reduces that way. So I end up having 3 over 10. Those are my numbers. And then I start doing the variables. So I have a squared in one numerator and a to the 7th. Division, I subtract. 7 minus 2 is 5. Where does it go? It goes in the denominator because that's where my largest exponent was to begin with. So I have a to the 2nd, a to the 7th. 7 minus 2 is 5. It goes in my denominator because that's where the larger exponent was to begin with. So I have a to the 5th. And then I have b cubed and b to the 1st. 3 minus 1 is 2. Once again, that goes in the denominator because that's where the larger exponent was to begin with. Whenever you have exponents like this, variables with exponents, just subtract the small one from the large one and put your answer wherever the large one is and be positive wherever that goes. Okay. Number 5, you need to factor. So my numerator is 2x and x, and let's see, 3 and 1, and that's a minus and that's a plus. Yeah. And x minus 3, x plus 3. So that's your first step, factor. My domain restrictions, x can't be plus or minus 3, because plus or minus 3 will make my denominator 0. Cancel anything I can. The minus 3's cancel. 2x plus 1 over x plus 3. Factor first. Get your domain restrictions from your factoring, and then cancel and whatever's left over is whatever's left over. Division, almost exactly the same thing. I need to factor, but I also need to invert and multiply. So if I factor the first fraction, the first one, I have 2x plus 1, x minus 3. Yeah, that one works for that. And then here I have 2x and x and minus 1 and minus 2. 1x, yeah, that's it. And then times, take the other one, invert it to factor it. X plus 3, x minus 3. And then factor the numerator there, put it in my denominator. 2x, x, minus 2 plus 1. Okay, my domain restrictions. My domain restrictions, x can't be, from my original one here, it can't be 2, can't be 1/2, 2x minus 1, I can't be 1/2 because of that. I can't be plus or minus 3 because this one, x plus 3, x minus 3, was in my original denominator here. So I can't have it be plus or minus 3. And then I need to check my final answer to see if there's anything left or anything in there that is not already covered. To get to that, I cancel. Is there anything else to cancel? No, sometimes it happens that way. Sometimes nothing cancels, which means everything that you have left is your answer. Here are the 2x plus 1's cancel. So I have x minus 3 squared times x plus 3 over 2x minus 1 and x minus 2 squared. If you wrote x minus 2 squared as x minus 2 times x minus 2, if you wrote x minus 3 as x minus 3 times x minus 3, didn't make it squared, I'm okay with that. I'm writing in the squares because I had 2 of them, and I'm conserving room. But if you leave it as all three separate factors, I'm okay with that. I don't have anything there that isn't covered by one of these. My domain restrictions are taken care of. Okay. Which problems require the use of a common denominator to simplify? What are we doing with the fractions? We are adding, subtracting, multiplying, and dividing fractions. Of those four operations, which ones require a common denominator? Adding and subtracting. So you go through, ooh, I have addition. This one requires a common denominator. This is division. Nope. Division. Nope. Multiplication. Nope. Multiplication. Nope. Oh, subtraction. I do have to do it there. It doesn't say solve the problem. It just says which one do you need a common denominator for? What do you need common denominators for? Adding and subtracting fractions. Yeah. Multiplication, division, you know. That's all that one is. Actually, probably this is the easy question of the test. Okay? This is the easy question. There's always one question on the test that's always much easier than everything else. This is the easy question. Now I have to do my adding and subtracting. So first I have to factor. So this is x plus 7, x minus 2. What do I have here that I don't have here? X minus 2. So I have 2x over x plus 7, x minus 2 plus, and then you do have to multiply out the numerator, 3x minus 6 over x plus 7, x minus 2 equals, my denominator is still the same, x plus 7, x minus 2, and then I combine up like terms, 2x plus 3x gives me 5x, and then I have a minus 6. I cannot factor 5x minus 6, so I can't reduce. I'm done. This one is a little more difficult, but not actually all that hard. So I have 5 12x squared y cubed minus. What do I have in this first problem that I don't have in the second one? So first of all, numerically, 4 and 12. What do I have to multiply 4 by to get 12? 2, 3, thank you. So I have to multiply that by 3 over 3. I'm not done, so I don't want to do anything. I'm just writing it down because I'm going to have other stuff. I have x squared here. I have only 1x here. I have to multiply by 3x over 3x. I have y cubed. I only have 1y here, so I need to multiply by y squared over y squared. That will give me a common denominator. My denominator, if I multiply this out, 12x squared y cubed, 12x squared y cubed, 12x squared y cubed. Do 1 times that. Ooh, that's easy. 3xy squared. I have one common denominator. So my answer is going to be over 12x squared y cubed. And then I have 5 minus 3xy squared. 5 minus 3xy squared. I can't combine 5 and 3xy squared. They're not like terms. So that's what I have. 5 minus 3xy squared. Doesn't cancel, doesn't reduce, doesn't do anything. Okay, simplify the complex fraction. So, my numerator, so what do I need to do? I need to invert and multiply. I need to take this and invert it and multiply it times my numerator. X plus 5, factor the denominator there, x minus 4, x plus 3, and take the second fraction, the denominator, invert it and multiply, x minus 4, x minus 3. X minus 4's cancel. And I get x plus 5 over x plus 3, x minus 3. Invert and multiply. That's what division is, invert and multiply. Take the denominator, flip it over, multiply times the numerator. You're good. Okay. So number 11, multiply everything times the common denominator, which is 7x. So multiply this times 7x, this times 7x, and this times 7x. On the first one, the x's cancel. I get 21. Here the 7x's cancel. I get plus 5 equals 4 times 7x, 28x. Ooh, one step, no more fractions. I like that. 26 equals 28x. Divide by 28. X equals 26 over 28, but we always reduce fractions, so we get 13/14. Always reduce fractions. Okay. Solve and check for domain restrictions. Cannot be solutions if they are restrictions. In other words, look for extraneous solutions. So solve it. Make sure you have your extraneous solutions. My domain restrictions on this one, I can't have 5. I can't have -4. X can't be 5 or -4. So if I get 5 or -4 as one of my answers, I have to toss that one out. And from here, to proportion, cross multiply. X plus 7 times x plus 4, x squared plus 11x plus 28 equals x minus 5 times x minus 3, x squared minus 8x plus 15. You know the shortcut when it's just x and x, right? Add the two numbers, throw an x on it, multiply the two numbers, that's what goes on the end. X plus 7 times x plus 4. X times x gives me x squared. How do I get the 11x? 7 plus 4 is 11. 7 times 4 is 28. -5 plus -3 is -8. -5 times -3 is 15. When you don't have anything in front of the x, it's really easy to multiply. Now, here's the cool thing is, I have x squared on this side and x squared on that side. They cancel each other out. It's not 2x and 3x squared or something like that. It's just 1x squared and 1x squared. Same amount on each side. If I subtract x squared from each side, they're gone. Now I just solve that equation for x. I add 8x and subtract 28. And I get 19x equals -13. Divide by 19. X equals -13 over 19. And that is not 5 or -4, so that's my answer. Really easy. I love it when something cancels like that, when the x squareds cancel. Oh, that makes it so nice. Questions? Okay. This one, multiply by the common denominator. Check for domain restrictions. So c squared minus 9 is c plus 3. C minus 3, so c can't be plus or minus 3. Anything else, I'm good. Plus or minus 3, garbage. What do? I multiply everything times my common denominator. My common denominator is c plus 3, c minus 3. So I multiply everything times c plus 3, c minus 3. C plus 3, c minus 3. C plus 3, c minus 3. C minus 3's cancel. I have c times c plus 3, c squared plus 3c. Here the c plus 3's cancel. I have 2 times c minus 3, 2c minus 6 equals, and here all of that stuff cancels, and I get negative 12. No more fractions, which is what we want. C squared plus 5c, combine them up, add 12 to both sides, plus 6 is equal to 0. Combine up the like terms, the 2 and the 3c. Add 12 to both sides to set it equal to 0. Two numbers to multiply to give me 6, that add to give me 5. C plus 3, C plus 2. 2 plus 3 is 5, 2 times 3 is 6. C equals negative 3, C equals negative 2. Negative 3 is no bueno. Negative 2 is my answer. Questions? Figure out the common denominator, multiply everything times that, cancel, reduce. Yeah, there's a lot of algebraic manipulation. That's the name of the game. The class is called Algebra 2, not Arithmetic 2. Okay, performance task part 1. There's 2 parts to it. You're leading a group of workers together that must clear several acres of tall grass. From past experience, you know that the number of hours H needed to clear the land varies directly as the number of acres A and inversely as the number of workers on the job. Use the information to set up variation problem. In other words, use H, A, and W and set up a relationship between H, A, and W. H is my first variable. So I'm going to have H, and W and A are going to be either times or multiply either one of them. Varies directly, ooh, that means I divide by A, and inversely as W, times W, HW over A. That's the relationship between those 3 variables, H, W, and A. Last time the work team was together, it took 8 workers 3 hours to clear 5 acres. Given this experience, how many hours would you expect it to take for 5 workers to clear 7 acres? In other words, 8, 3, and 5, 8 hours, 8 workers times 3 hours to do 5 acres is equal to how many hours will take 5 workers to do 7 acres? Plug in the numbers. Okay, what am I looking for? I'm looking for H in the second one. So 8 times 3, 24 over 5 equals 5H over 7. Cross multiply. 24 times 7, 140 plus 168. Yeah. Not bad. So I get 168 is equal to 25H. H equals 168 over 25. And you should divide that out in order to get a decimal on this one, because 168 over 25 hours does not make sense, does it? 168 25ths of an hour makes no sense. But if you divide it out, and that would be 6 and 6 point what? 0.7, thank you. Yeah, 6.7 hours makes sense. That makes sense. Do you see what I'm saying on that one? Now, if you were to give me the fraction 168 over 75, would I mark you wrong? Probably not. But remember, your answer should make sense of the problem. 168 25ths doesn't make sense. 6.7 hours, that does make sense. Okay, you are in the business of producing and selling wood chips that are used as landscaping ground cover. As part of forecasting revenue and production costs for your business, it is important to understand the relationship between the volume of the wood in a tree, the height of the tree, and the girth, the distance around the trunk of the tree. You know that the volume of wood in a tree varies directly as height and inversely as the square of the girth. Volume varies directly as the height, right? Then an H. V over H times G squared. Inversely is one, directly is one, inversely is the other. So V divided by H and times G squared. That's your relationship. Plug in the numbers. If the volume of a small tree is 130 cubic feet, when the height is 35, and the girth is 1.5, squared, don't forget the square, that's the most common mistake on this one. Find the height of a tree with a volume of 600 cubic feet and a girth of 25 feet. 600 over H and 2.5 squared. And yeah, you're going to want a calculator for this one.
Oh boy.
And you get 448.7. Questions? What? Okay. So, any more questions on this problem?
Wow.
You got it?